For today's lecture, we will be studying about vector calculus. So we will be dealing with vector differential calculus and vector integral calculus. So in engineering, mathematics, or physics, we often use vector functions in three-dimensional spaces. So today we'll first review some of the aspects of what a vector is, and later on we will apply it to three-dimensional. Okay, so in mathematics, you often encounter two basic quantities. You have scalar and vector quantities. So scalar is quantity that determines only by its magnitude. So sample ini is time, okay? Temperature, length, distance, speed, density, energy. So these quantities represents only its magnitude, no? So kakabalo, wala na siya direction. In relation to that, a vector quantity has both magnitude and direction. So this is a representation of vector. You have an arrow, no, which has length and direction. So it is represented by a bold letter A. Pero kung isulat nimo na siya, usually ginabutangan nimo og arrow sa taas to represent that it is a vector. So point P is the initial point, and this point Q is the terminal point. So the distance between P and Q is called the length or the norm of the vector. Now, if the length of the vector is 1, so this is called a unit vector. So vectors are equal if they have the same length and direction. So sample of this one is ay upat ka scenario diri. Vector kaning A mora ni ang equal, no? Has the same length and direction. Whereas kani same length but opposite direction, di din sila equal, as well as this one. In order to determine the components of a vector, so you need to get the distance between the different coordinates. Okay? So, i-minus nimo ang x coordinate sa terminal point minus the x coordinate sa initial point. So, mao na ang x component sa imong vector A, as well as for y and z. The same process. Now, if you want to get the length or the norm of the vector, you just square the component of the vector and then you add and get the square root, so that will makuha nimo ang length ana niya. So to add vectors is you add the corresponding component. Sample a1 plus b1, so this is the first component sa imo ang a plus b na vector. Okay, so you just add the corresponding components. Now if you by the way, these are the properties of addition. Commutative, associative, no? Pwede kani imong una i-add or pwede pud kani una. Okay, mas lag answer. Scalar multiplication is you just distribute the scalar quantity. So ninani ang mahitabo sa iya, no? So this is the original vector. Kung multiplyan nimo 2, so mahitabo is mo twice ang iyang length. Multiplyan nimo by negative 1, change ang direction, as well as this one. Again, these are the properties, basic properties. Inner product. So let's proceed with inner product or the what we call the dot product. Now, kaning dot product and cross product. So this is how you multiply vectors. When you say dot product, so dot product of the vectors is the product of their lengths times the cosine of their angle. Okay, so ang sabot dayaning dot A dot B is multiply the length times the angle between them. Okay? So, kung saan man ma-zero ang dot product, ma-zero ang dot product when the angle is 90, no? Pasabot ana, if perpendicular ang imo ang vector, ang dot product niya is 0 or what we call orthogonal vectors. So, kung gusto nimo mahibaw-an kung orthogonal ba ang duha ka vector, ay imo ning dot product ang ilang duha. Kung 0 ang answer, pasabot ana, orthogonal sila. Kung dili 0, so it can be ani or okay. Again, this is how you get the angle between them. Okay, that product of the vector divided by the length. Multiply ang duha ka length nila. Okay, so ang inner product nimo will I dot I is equal to 1. Ano man kay ang I dot po nimo og I, so cosine 0 is 1. So mo na siya. Na kung perpendicular na 0. Okay, cross product. Ang cross product is ang value po niya is AB the length times sine gamma. Okay? And again, ang value ani niya kay sine man, so kung sa ma-zero na siya, when sine 0 is 1, sine 180. So kung same direction ang duha ka angle, 0 na ang iyang cross product kay wala man sila ng cross. Okay, so when you cross A and B, the resulting vector, ang direction na is perpendicular sa plane ani nilang duha. No? Perpendicular na yung plane nila. So, in pag-visualize nimo ana, you can use your right hand, no? So, A cross B, going upward ang imo ang resulting vector. Okay, so this is how you cross product two vectors. First is cofactor, no? I. So, mabilin ani. Again, this is just a review. So, kani ang mabilin. Times I, dayon. Plus, minus, plus. So, minus na po. For J, A1, B3, and A3, B1. And so on. Okay, so this is just a review. These are the properties. Okay. Cross product is not commutative. No? But anti-commutative. So, B cross A is equal to the negative of A cross B. Mo din siya. You have also scalar triple product. No? So, you have cross product and then ang result niya imong dot product. So, again, ang buhaton nimo ani is imo sa ning unahon og cross ning duha. Then you apply that product. Okay, these are the properties. So equal ra di ay ang pwede ra ma-interchange. No, pwede cross nimo na ang B ug C or cross nimo na ang A ug B. So ang geometrical interpretation niya is mura ni siya og volume, no? Mura ni siya og volume ano man kay diba B cross C man to. So B ang B then gi-cross sa C. Ang plane nga perpendicular ana niya is kani. Ay, so mo ni ang result. Mo ni ang result and then you apply that product so gikuha nimo ang component ani nga with respect to A. So mura na siya ang resulting niya volume sa parallel pipe. Okay. So those are just review. So we will focus now on the vector and scalar fields. So unsa man sila? So this is an example of a vector field. Okay? So this is a CFD simulation of a car, no? So lahi-lahi og configuration ng mga car. So, ang first nga car is closed type, no? Close. Then ang B ug C B2 E di ay open ang top. Okay? Na-open nga top nga flat og diri nga part likod. And then yung gibutangan og ninani. So this is a vector field because kaning mga color this represents the velocity, no? Unsay nahitabo sa velocity as it passes through the car. So ang pinaka best nga design is kaning close, no? Close na sedan. Oh. Ano man kay na-minimize niya ang drag. Kani this represents drag man ni. Ang kanang drag nimo say mag-oppose sa imo ang motion. So in return mas dako ka og fuel nga ma-consume nga naman kay naa pa man kay counteract nga force of drag diri. No, as compared nimo ani o mas diri ra nga part ang naay drag. Okay? Diri nga part which is less compared ani nila. Okay? So dili ta kabalo ani nga insight kung walay mga nin-ani nga type of analysis. And then giunsa man ni siya pagbuhat through the knowledge of vector fields, no? So mo ni ang car nimo sa imong ang simulation mo ni ang mga vector field, vector functions nimo. Ni oh. So giunsa man na siya pag-plot. Mo na tong buhaton karon. And then this is a example of a scalar field. So makita ninyo wala siya arrow but lang kanang color lang which represents the value kay temperature man eh. This is a sample of a temperature distribution sa imong engine, no? Tan-aw nimo kung ang mga part na tag-as og temperature. So obviously diri jud sa inside sa cylinder sa piston nimo, no? Kay diri man ang combustion. Okay, so kani gid ang exposed to high temperature. And then mahibaan nimo ang temperature distribution nila. Kabalo ka nga unsang mga material ang appropriate diri. Okay? So a vector field in three-dimensional space is a vector whose components are functions of three variables. Okay, so this is a This is how you write a vector function. Okay, so ang component niya is also a vector function. This one. So these are examples of vector function. Okay, so ang question ani, so kani nga mga arrows, mo ni kadto mga arrows nga nakita ninyo kaganina. Okay, so if you know the equation of this, yung same equation ani, sa velocity nimo, ma-plot na nimo siya. Sample ni ani. Okay. So for today, we will study how to plot these vector functions. Sample kani siya. Anong nanin-ani man ni ang plot. Okay. Again, this is duha ra ka variable ni siya. Kani 3 variables, so you have x, y, z. Okay. Okay, so kung na-plot ni siya because of kabalo siya sa equation sa vector field. No? So, ma-plot ni mo na siya if you know the equation. Okay, so let's have this vector function and let's try to plot this one. This is function only of x and y. Okay. This is your x, this is your y. Okay. So what you're going to do is plot some values. Sample function of 0, 1. Okay, so this is your x and y values. So matabuan na, you have 0i minus j. So asa ang 0, 1 ani? This is 1, 2, 3, 4, 2, 3, 4. Okay, ang 0, 1 nimo is, klaro ba? Kani 0, 1. So 0, 1 is 0i and negative j. So negative j paana. Okay. Okay, paana. Klaro ni. Klaro pa na. Okay. Function of 1, 1. So may tabuan 1, 1, negative I, negative J. So ang 1, 1 is kani. Right? Okay. 1, 1 kani. 1, 1 is negative I. So negative I, negative J. So paano siya? So makita ninyo, ang terminal point niya is nasa 0. Try tag other values. Function of 4, 4, 1. May mo ning negative 4 I, negative J. Ang 4, 1 is kani 4, 4, 1. Diha, no? Diha ang initial point. So negative 4, ana, negative J. Dili gid sa 0, no? Dili sa 0. Try tag other value. 4, negative 3. So 4, negative 3, 4, negative 3 diri. 1, 3. So negative 4 I plus J. Ano? Plus J plus 3J. Ang 4, negative 3, 4, negative 3 kani. So yun siya, negative 4. So negative 4 plus 3j. Diri gyapon. Ana gyapon. Ana gyapon no. Try tag diri nga value. F negative 3, negative 2. Charo. 3i plus 2j. So negative 3. 1, 2, 3. Negative 2 kani. Negative 3, negative 3. Dagan kag 3, angat kag 2. So diri gyapon sa 0. Diri gyapon sa 0. No, so kani nga vector function, no, kung example diri ang point nimo, diri gyapon na siya. Ana siya, no? Diri mong point, ana gyapon na sa diri. Balik gyapon na siya, ana. No, so this is how you plot kanira ang equation pod, no? Ang depend sa equation. Ano nga equation? Ang terminal point nga is mo end sa 0. No, sa mura siya og mura sag sink, no, mura sag sink. Tanang flow niya kay mo sulod diri. So this is how you plot a vector function. You just assign values of x and y, then locate that point in the graph. Dayon, sundo na dayon ninyo ning asa ni siya nga dakit. Okay? Partial derivatives of a vector function. So if this is the vector function, so to compute the partial of z with respect to x, so we use the law of ordinary differentiation while treating y as a constant. So ang buhaton na to is we use the ordinary differentiation, but we treat the y value as a constant. So in example, this is the vector function 4x cubed y squared minus 4x squared plus y to the 6 plus 1. What is partial of z with respect to x and partial of z with respect to y? So the partial of z with respect to x, so we treat this variable as a constant, so kanira itong i-differentiate. So you have 12x squared y squared minus 8x, and then kani, since this is a constant, so the derivative of this one is 0. As well for partial of z with respect to y, so kaning value are constant, so you have 8x cubed y, and then kani is 0, and then 6y to the 5. So mo na siya. Now, there are alternative symbols for the partial derivatives. Example, partial of z with respect to x, pwede nimo siya isulat ninani or ninani. Okay? For second order partial derivative, again, kung unsa tong value sa imo ang first derivative, imo ra siyang differentiate again. So for third order, for mix second order, so sample kani partial of z with respect to y, you differentiate this one with respect to x to get this one. Okay? As well as for tanaw ninyo partial second mix second order, partial of x, partial of y. So ang first nimo nga differentiate is kaning with respect to y. And then sunod with respect to x. Kung ninani, first is with respect to x. Ano? Kung unsa ang nasa ulahi. But yun niya dere, if a function f has continuous second partial derivatives, then the order in which a mixed second partial derivative done is irrelevant. So, fxy is equal to fyx daw. Gani. If f has continuous second partial derivative. Okay, chain rule. When will we use chain rule? So, we use chain rule if the variable y is a function of u and u is function of another variable. Okay? Okay. So, ang buhaton ana is, first is the derivative of y with respect to x is equal to, differentiate nimo una with respect to u and then differentiate u with respect to x. So, kung tanaw nimo ra sa mo cancel out ang u. Kaya bilin. Okay, so for example, this one. The function z is function of u and v. But u and v is function of x and y. So, ang buhatan na ang partial of z with respect to x will become partial of z respect to u, partial of u with respect to x, partial of z with respect to v, and partial of v with respect to x. As well for partial of z with respect to y. Kani pwede mong buhaton. Okay. Example. You have z is equal to u squared minus v cubed. So, ang u function is equal ani? Function siya of x and y. So, find partial of z with respect to x. Again, ang equation ato with respect to x. Kani, timan mo ni. No, memorize ni mo ni. With respect to x tanan. Ang buhaton ni mo, partial of z with respect to u is equal to 2u. Partial of z with respect to v is negative 3v squared. And then, ano na din gamiton nimo no? Partial of z with respect to x. So, unsa ito? Partial of z with respect to u. So, kani 2u. And then, partial of u with respect to x. So, with respect to x, ang answer ani is 2 e to the 2x minus 3y. Constant ra nimo ni. Kaya ang derivative man sa e to the u is, ay e to the something is e to the exponent, and then differentiate the exponent. And then, plus partial of z with respect to v, kaniman sa mo ni, minus 3v squared. And then, differentiate v with respect to x. So, ang differentiation ani is cosine x squared minus y squared times 2x. So, muna dahil ni. So, partial of z with respect to y, you have partial of u with respect to, partial of z with respect to u, 2u, and then partial of u with respect to y. So, kung with respect to y, mahimo ning negative 3 e to the 2x minus 3y. So, the answer is this one. So, dali naman siya, no? Dapat careful lang ka. For special case, kung special case meaning, ang imong z partial function of u and v, but u and v as function of one variable. So, kung function of single variable, hindi na siya partial, no? Kaganina is partial man eh. So, kung function siya of isa ka variable, may mo na siyang ordinary derivative, dz over dt, or what we call total differential, no? Hindi na siya partial, total na. So, again, buhaton nimo partial of z with respect to u, and then differentiate u with respect to t. So, kapoy mag-memorize, so naa kay tree diagram, no? Sample kani, ang z nimo function of u and v. So, imong buhaton is, sulat nimo ang z, function man sa duha ka variable, so butang nimo ning duha ka bracket, u and v. And again, ang imong u is function of two variable x, y, so ana. So, kung kuhaon nimo ning partial of z with respect to x, no? So, kani. Kung with respect to x, so z padong sa x. Z padong sa x. So, i-add na nimo. Kani, so ito, partial of z with respect to u times partial of u with respect to x plus partial of z with respect to b and times partial of b with respect to x. So, kaning duha, multiply plus kani. Kung with respect to y, tiri na po ka. Partial of z with respect to u times kani. Plus kani. For single variable, diretso ra na. Plus nimo. Kung function of three variable, x, y, z, u, v, s, same ra gyapon ana plus kani plus kani. Okay? Sample. R is function of x, y, and z, but x is function of u, v, s. So find partial of r with respect to s. So partial of r with respect to x, s is kani, no, based sa tree diagram. Partial of r with respect to x, partial of x with respect to s. Ano ang gina to na? Kani, di ba? Kani, partial of r with respect to x, x with respect to u. Tutulo siya ka component plus kani plus kani. Yang gipangayo kay with respect to s man, so kani. Partial of r with respect to x, partial of x with respect to s. So, ani ang dagan? Kana plus na. Okay? So, imura din yung pang-differentiate. R with respect to x. So, with respect to x, 0 ni 2x. So, man ni 2x. Partial of x with respect to s. Yan eh. Constant ni. So, may maning 2 uv e to the 2s. Plus partial of r with respect to y. R with respect to y. So, 0 ni. May maning 5 y to the 4th z cube. And then y with respect to s. Kani. So, may maning 0, negative 2 vs. Oh, negative 2v. Kay y with respect to negative 2v, negative v squared. Okay, constant man eh. And partial of r with respect to z. So, may maning 3 y to the 5z square. Kani. Times partial of z with respect to s. Kani. May maning cosine uvs squared 2uvs. Single variable, okay? So, that's it for today's discussion.